Hey everyone, Miss Marion here. Make sure that you have grabbed Unit 7 workbook, and on the front page you need to go ahead and put in Team Loki, your name, and then also the class period, because then again this makes it so that it goes back to you, because everyone in the whole entire school actually has the same color of workbook, both 6th, 7th, and 8th. So make sure you put your name on it, Team Loki, and then the class period, and it'll come back to you. All right, let's turn page 125. That's where our I can statements are. We are just looking at lesson 1 for today. I can use exponents to describe repeating multiplication, and I can understand the meaning of a term with an exponent. Go ahead and give yourself a number. So 1, I don't remember. 2, I kind of remember it. 3, I do remember it. 4, I can teach it to my friend. Give yourself also a sentence, how you feel about this. Exponents are new. So if you are like, hey, I'm unsure about this, that's fine. Because again, exponents are new. So go ahead, number, and then a sentence. Do that, and then come back to me. All right, so let's go ahead and turn to page. So we are turning to page 7. Page 7. And on page 7, we have these expressions, and you are answering the question, which expression doesn't belong? So blank doesn't belong because of blank. Write this in your workbook underneath this picture, which one you think doesn't belong. Once you've done that, so go ahead and pause, do that, and then once you've done that, come back to me. So you could say that the first one doesn't belong because it has a 3 exponent. 8 doesn't belong because it's just a number without an exponent. This one doesn't belong because it has the base. Base is 3, see that big 3 and then a 2. All the other ones have like the 2s. And then you say the bottom one doesn't belong because it has 2 of the different things along with it. So any of these can not belong because of different reasons. Is there a certain actual answer? There is not, but just kind of keep that in mind. All right, so on page 7, on the bottom page 7, and it will go into page 8 as far as answering the questions. It says, Maya and Andre found an old brass bottle that contained a magical genie. They freed the genie and offered them each a magical 1 coin as thanks. The magic coin turned into 2 coins on the first day. The 2 coins turned into 4 coins on the second day. 4 coins turned into 8 coins on the third day. This doubling pattern continued for 28 days. Maya tried to calculate how many coins she would have and remembered that instead of writing the 1 times 2 times 2 times 2 times 2 times 2 times 2 for the number of coins on the 6th day, she could write it as, sorry, my exponent didn't come through. She could write it as 2 to the 6th power. The number of, so number 1, this is on page 8, but it's also on this here. It says, the number of coins Maya had on the 26th day is very, very large. Write an expression to represent this number without computing its value. So go ahead and pause, write that down, and then come back to me. All right, so the answer that you should have had is 2 to the 28th power. So up here, it says Maya did it for a number of 6 days. She had 2 to the 6th. So because it's the 28th day, it will do 2 to the 28th. All right, number 2, Andre's koi lost their magic on the 25th day. So Maya had a lot more coins than he does. How many times more coins does Maya have than Andre? So go ahead and answer that question and then come back to me. All right, so if we look at it, let's kind of make some room. Let's move this up. So Maya, she had 2 to the 28th. And then Andre, he had 2 to the 25th. So if you look at it, so we have 28 here, we have 25 here. There are 3 more 2s that Maya actually has. So she has 3 more 2s. So she actually has like 2 to the 3rd power. And if we want to figure that out, that is 2 times 2 times 2. Or you can put it in your calculator. But she has 8 times more coins. And it's because of it doubling every day. So she has 3 days more, and it's doubling every day. And if we multiply those together, it's 2 times 2 times 2. So if we look at it, we can actually write these also as exponents. If we really wanted to put that, we could do it as, notice how we wrote it as an exponent. We can also multiply it out and figure out what that amount is. So today, and for this whole unit, we're actually talking about exponents and how they actually go ahead and look at different things and how they work. So if we look at this table, notice how we have 2 that can be written as 2 to the first. If we multiply that out, it is 2. We have 2 times 2 times 2 times 2. This is 2 to the fourth. If we multiply that out, that is 16. And then we have 2 times 2 times 2 times 2 times 2 times 2. So there's 1, 2, 3, 4, 5, 6. So 2 to the 6. If we multiply that out, that is 64. So again, if we wanted to go ahead and look at it, we could say how many times larger is 2 to the 6th than 2 to the 4th? So if we kind of think about it, so 2 to the 4th, all right, 2 to the 6th has 2 more than 2 to the 4th. Okay, so we can go and look at it. So how many times more does it have? Well, we're going to say 2 to the 2nd, and that's 2 times 2. So then that would be 4. So it has 4 times more. Okay, so notice how like there's 1 there, 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 1 there. Oh, look, that's the 2 to the 2nd, which is 2 times 2, which is 4 itself. Or if we can actually look at the value itself, if we say, well, how many times more does it have? We could actually say 64 divided by 16. That also gets our 4. So there's many actually different ways of figuring this out. I like to look at it as, oh, how many more 2's does it have? Multiply it out, and then we get that number. All right, so let's go ahead and look at page 88. Bottom of page 8 goes into page 9. We're going to talk about the broken coin. So instead of making it bigger, kind of makes it smaller. So after a while, Jada picks up coin that seems different than the others. She noticed that the next day, only half of the coin is left. On the second day, only 1/4 of the coin is left. On the third day, only 1/8 of the coin is left. What fraction of the coins remain after 6 days? So what I want you to do is go ahead and try that, and then come back to me, and we'll figure that out. All right, so I'm looking at the first part, and it says the second day is 1 to the 4th. So as we did before, instead of saying 2 to the 2nd, that means I have 2 1/2. If I multiply that together, it is 1/4, but I can also say 2 to the 2nd power, and I can also say 1/2 raised to the 2nd power. All of these actually mean 1 to the 4th. So then let's look at the third day. So the third day, so that's 3 1/2. That's 1/2 to the 3rd. Or notice how I write the exponent this way, where it says the 1/2, the parentheses put it on there saying it's the 1/2, the whole 1/2 is being raised to the 3rd power. And then all of this is the 1/8. So if I was looking for 1 to the 6th day, that means I'm going to take 1/2. And how many times am I going to multiply that together? Well, I'm multiplying it 6 times. Or, and if you try that in your calculator, if you kind of put it in the way it is, some of them don't give you it only gives you a decimal back. So I'm going to show you kind of how to do it without having that issue. So I know it's 1/2 and then raised to the 6th power. So grab your calculator, let's do 2 raised to the 6th power. What is that? Oh, it's 64. So what is the fraction? Because it asked for the fraction. It's going to be 1/64. All right, so let's look at number 2. What fraction of the coin remains after 28 days? Write the expression to describe this without computing its value. So an expression. Go ahead and pause, try that, and then come back to me. All right, so how can we write this as an expression? So there's a couple ways we can write it, and if you look at it, we can say 1/2 to the 28th, because it was 28 days, or we can write it with the parentheses, 2 raised all the way to the 28th power. So this is the way that we actually have it. We can also talk about 1/2 being multiplied by itself 28 times. That's a little bit harder because it does deal with words, right? Sometimes words and math don't go along, but these are different ways of writing as an expression or with an exponent. Because today, so this whole unit, again, we're going to be talking about exponents. All right, so let's look at number 3. Does the coin disappear completely? If so, after how many days? So mathematicians always have fights about this. So how does it actually go? Well, actually, no. The coin never completely disappears because each time that half of the coin disappears, there's still a half left. Now, can it make it really, 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 really small? Yes. But does it ever disappear? No, it doesn't. And so it's kind of hard to wrap your brain around this, but actually that is the answer. No, it never does. Now, it might be really, 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 really small, and you might need a microscope to see it, but it never goes away. All right, so again, today we're talking about exponents, right? So what does it mean when you write 2 to the 42nd power, 42nd power? Yeah, 42th, yeah. 42nd power. Well, that means that we're taking 2 and we're multiplying it by itself 42 times. So 2 times 2 times 2, 42 times, okay? How many times larger is 2 to the 45th than 2 to the 42nd? So if you want to think about as far as answering that, if we do 45 minus 42, that is 3. So that means we're saying 2 times 2 times 3 times, which is 8 times more. And we'll be dealing with that a little bit further. What does it mean when I write 1 over to the second for the 42nd power? That means I'm going to take 1/2. I'm going to multiply by itself 1/2, 42 times. Okay? And then think about it. Which one is greater? 1/2 to the 42nd power or 1/2 to the 45th power? Now, actually think about it. Remember, the more and more we multiply 1/2 by itself, it makes it smaller and smaller and smaller. Okay, so which one is actually greater? That is actually 1 over the 42nd power, okay? So again, we're talking about exponents today, and we're trying to figure out those kind of things and understand how to write different things different ways. So hopefully we understand that. So again, today we did I can use exponents to describe repeating multiplication, and I understand the meaning of a term with an exponent. So again, today's exponents kind of stuff. So today we're going to be doing Unit 7, Practice Problems, Lesson 1, and those are in Canvas, so make sure that you go through that in your workbook and upload the answers into Canvas, and that is all that we're doing for today. So have a good day. Bye.